For this signal flow graph, we don't have any output. But if we do a modifying on this SFG means signal flow graph, okay? If we do a modification on this signal flow graph, as like that, now what can we say? What is the output? Y3 is output because as you see here, Y3 node has only incoming branch. If you want to get Y2 as output, so you can do the same operation on this node. As like that, we can do a modification on the Y2. Now we can say the outputs are Y2 and Y3 for this SFG. Okay, let's continue now. What about the path? A path means actually branch. A path is only collection of a continuous succession of branches traversed in the same direction. Okay, as you see here, this is a path, this is a path, path and path. What about the forward path? Forward path is a path that starts at an input node and ends at an output node, and along which no node is traversed more than once. It's important. For example, for this signal flow graph, if we have Y3, for this SFG, as you see, Y3 is output for us, and Y1 and Y2, as you see, input. Maybe we don't consider the Y2 now. Yes, what is the forward path for us? Starting from the input node and we'll go to the output node. How can we path? We can continue. As you see, we can continue from the Y1, Y2 and Y3 node. Okay, we can say this path is forward path. Maybe we can talk about more for the forward path. In here we have more complex signal flow graph. What do you think for this diagram? What is the input and what is the output? For this diagram we can say Y2 is input because as I said before, input node has only outgoing branch. Okay, as you see here, Y1 and Y2 has only outgoing branch, considering the arrow direction. Input because of the only outgoing branch. If you consider the Y2, for example, Y2 has incoming and also outgoing branch. So Y2 cannot be an input or output. Y5 is output for this diagram. Maybe we can examine in detail. Let's talk about the Y5. We have two branch and which come from anywhere, but we don't have any outgoing branch, so Y5 can be evaluated as output. Okay, let's talk about the now forward path. Forward path start from the input and will go to the output. How can we go to the output? Let's examine it. We can use all of these branches, as you see. Forward path can be Y1, Y2, Y3, Y4 and Y5. What about more? We can use this direction, as you see. So the other forward path for us, Y1, Y2, Y4 and Y5. Okay, what about more? If we have, let's look at this diagram again. As you see here, we have one more forward path. It is Y1, Y2, and y5. So we can say for this diagram we have 3 forward paths. Yes, path gain. Path gain means, as you see here, a1, 2 is a path gain between the y1 and y2. Okay, it is the path gain. What about y1 and y3? As you see here, we have 2 path gain. Which one of them is from y2 to y3? a2, 3. What about the other from y3 to y2? It will be a3, 2. Okay. Loop. What about the loop? Let's evaluate this diagram again. Loop is starting from any node and will go to the same node again. Let's examine this diagram. In here, as you see, we are start from y2 and we'll go to the y3 and again we'll go back to the y2. It's a loop, okay? For this diagram, we have one loop starting from y2, we'll go to y3 and we'll go back to the y2. What about the more complex SFG diagram as like that? Let's look this diagram for the loop. Yes, loops. As you see here, we have a loop starting from y2, y3, and we'll go back to the y2 again. y2, y3, and y2. What about more? From y3 to y4, and again we'll go back to the y3, y3, y4, and y3 again. What about more? In here we have a loop also from y4 to y4. What about more if we have? Yes, we have also one loop in here. Starting from y2, we'll go to the y4 and then y3 and y2. Okay, starting from y2, we'll go to y4, y3, and y2 again. As you see here, this is another loop. What's more, if we have a loop is a path that originates and terminates on the same node and along which no other node is encountered more than once. Okay, it's important. No other node is encountered more than once. Forward path gain. For example, in here we have again y3 here as output, and we have only one forward path, which is y1, y2, and y3. That's all. For this forward path, we can say this forward path has a12 times a23 forward path gains. Okay, maybe we can talk about on the more complex diagram again. In this diagram we have 3 forward paths and we can write 3 forward path gain. For example, for this forward path from y1 to y2, a12 times y2 to y3, we have a23. From y3 to y4, a3, 4, and y4 to y5, we have a4, 5. This gives us to forward path gain, okay, for this forward path. What about this? a1, 2 again, y2 to y4, we have a2, 4, and also a4, 5. What about the others here? y1 to y2, a1, 2 again, y2 to y5, we have a2, 5. It is the forward path gain. Loop gain. Let's talk about loop gain now. For example, for this diagram, we have a loop as you see here, and for this loop we have two gain which are A2 3 times A2 3 A3 2. Okay, this is the loop gains. Maybe we can talk about on it again. In here we have 3 loop. Let's write the loop gains for this diagram. For this loop gain will be A2 3 times A3 2, as you see here. For this loop we have A3 4 A4 3. This loop Y4 to Y4 we have A4 4, and the last one we have a loop as like that. It will be A2 4 A4 3 and A3 2. Okay, these are loop gains for these loops. Okay, yes, what about the non-touching loops? Non-touching loops, two parts of an SFG are non-touching if they don't share a common node. Okay, it's important. If they don't share a common node, so we can say they are non-touching. Okay, non-touching loop. For example, in here we have already one loop, so there is no non-touching loop for this diagram. What can we say about this diagram now? Is there any non-touching loop which don't use the same node? Let's evaluate this one and this one. As you see here, they don't use any common node. Okay, so they are non-touching loop. Is there any other non-touching loop? I cannot see. There is no other non-touching loop for this SFG diagram. Two parts of an SFG are non-touching if they don't share a common node, as I said before. Gain formula for the SFG. By using the SFG, we can find transfer function of a system. Okay, in here we have a formula as you see. Y out over by Y in. It will the sum of mk delta k over delta. What is Y in? Y in is input node variable. Y out output node variable. M is the gain between Y in and Y out. N, as you see here we have N. And total number of forward path between Y in and Y out. Okay. Mk, gain of the kth forward path between Y in and Y out. Delta can be given as 1 minus sum of something plus sum of something minus sum of something, and it will continue as like that. What is the something here? It is the sum of the gains of all individual loops. Okay, all individual loop gains, and it will continue sum of product of gains of all possible combination of two non-touching loops. And it will continue if you have 3 non-touching loop, and it will continue if you have 4 non-touching loop, and as like that we can continue. We have also here delta k. What is delta k? It is the delta for that part of the SFG that is non-touching with the kth forward path. It's about only using forward path. Okay, not all of the system. Let's do an example. You will understand easily. Let's find the gain of this system by using the SFG. Let's do this question now. We have this kind of SFG diagram. How can we find the M? M means ys over rs. How can we find it? As you see here, this is the formula for us. mk delta k, and delta k is starting from 1. Yes. What is the forward path for this diagram? As you see here, we have only one forward path. Forward path only rs, es, ys. That's all. So what is the forward path gain? Here gs. We don't have any gain for this path. What about the loop? Yes, what about the loop? As you see here, we have only one loop. Starting from es, we'll go to the ys and we'll go back to the es, which has the gain minus hs and gs. Okay, we have only one loop for this question. Starting from es, ys, and then we'll go back to the es. Okay, so the loop gain for this question, loop gain will be minus gs hs. Okay, let me find the delta now. Delta will be equal to 1 minus the loop gain. Loop gain, we have only one loop, so it will minus gs and hs. It will continue from two non-touching loop. For this question, do we have any non-touching loop? No, because we have already one loop, so we cannot say we don't have any non-touching loop for this question. So delta will be 1 plus gs hs. So we can do this question now. M will be equal to m1 times delta 1 over delta. What is the delta 1 now? Delta 1 is about the only related forward path. Related forward path, we know rs, es, and ys. So it will be 1 minus. There is any non-touching loop for the related forward path? No, because as you see here, all loop will continue on this path. So we can say 0 for it. It will 1. So m1 is gs, the related forward path gain. Okay, delta 1 is 1 and delta is 1 plus gs hs. So it will be gs over 1 plus gs hs. That's all. Okay, let me continue from another example. Consider the SFG shown in figure 4.28d. Let's do this question now. Let me talk about this diagram now. What is the forward path? Forward path gain, loop gain. We need this kind of information for the SFG algebra. Forward path starting from y1, y2, y3, y4, and y5. For this path, we have a12, a23, a34, and a45. What is the another forward path for this diagram? Starting from y1, y2, y4, and y5. what is the forward path gain? A1 2, A2 4, and A4 5. What's more, we have Y1, Y2, and Y5. What is the gain for this forward path? A1 2, A2 5, and that's all. We don't have any other forward path, as you see. So what about the loop now? What about the loop? We have Y2, Y3, and Y2 again. For this loop, we have A2 3 and A3 2. Okay, what about more? We have Y3, Y4, and Y3 again. For this loop, we have A3 4 and A4 3. The other loop is Y4 to Y4. It will A4 4. And the other loop is starting from Y2, Y4, Y3, and Y2 again. So we have A2 4, A4 3, and A3 2. We don't have another loop. So for this loop, as I said before, we have also non-touching loop. Okay, non-touching loop. What is the non-touching loop? Let's write it now. Non-touching loop. For this question, we have two non-touching loop, which is Y2, Y3, and Y2 with the Y4 and Y4. So the related non-touching loop gain will be A2 3, A3 2, and A4 4. This is the non-touching loop gain. We don't have any other non-touching loop. Okay, we don't have any other non-touching loop, so we can write the gain. What is mean for us? Yes, this is M1, M2, forward path gain, M3. We need also delta, delta 1, delta 2, and delta 3. Let's get the delta before. Delta is about the all SFG diagram and regardless of the output. Okay, it's important. Delta is a general information for a unique SFG, and it is regardless of the output. Delta is equal to 1 minus loop gain. As you see here, we have 4 loop gain, so we should write it A2 3, A3 2 plus A3 4, A4 3 plus A4 4 plus A2 4, A4 3, and A3 2. That's all for the loop gain. What about more? If we have, we will continue from plus sign because in here minus, we will continue plus. What is the non-touching loop gain? We have one non-touching loop with each other, and the non-touching loop gain will be A2 3, A3 2, A4 4. So we don't have any other non-touching loop. If we have 3 non-touching loop, we will continue from this part. If we have 4 non-touching loop, we will continue from here. Okay, it will continue as like that. But for this question, we don't have 3 non-touching loop, so this part will be 0. We don't have 4 non-touching loop, so this part will be 0 and it will continue as like that. What about the delta 1? Delta 1 is only related to the forward path. What is the forward path for delta 1? A12, A24, A34 and A45. As you see here, for this forward path, we use all of the nodes. Y1, Y2, Y3, Y4 and Y5. We use all of them. Okay, so there is no non-touching loop for this forward path. We can say 1 minus, there is no non-touching loop, it means 0, it will be 1. What about delta 2? Delta 2 is about M2 and for this part we use Y1, Y2, Y4 and Y5. What can you say? Is there any non-touching loop related to this forward path? Yes, we don't have any non-touching loop for this path, so delta 2 will be also 1. What about delta 3? 1 minus, what is the forward path? A12 and A25. As you see here, we used Y1, Y2 and Y5 node. Is there any non-touching loop for this forward path? Is there any loop which don't use the Y1, Y2 and Y5 node? Okay, what can you say about this loop? For example, Y44 is a non-touching loop for this forward path, okay? Because they don't use the Y1, Y2 or Y5 node. What else? As you see here, we have one more non-touching loop, Y3, Y4 and Y3. It means it doesn't use the Y1, Y2 and Y5 node also. What about more? We don't have any other because as you see here for this loop, we will use Y2 and here also Y2. Okay, so we have 2 non-touching loop for this forward path. Okay, let's continue by using this loop gain. 1 minus A44 plus A34 A43. Okay, we have to consider this non-touching loop. Let me continue now. We found delta 1, delta 2, delta 3. We found forward path. So we have all needed part for the gain. M will be equal to Y5 over Y1 and it will be Y1 times delta 1 over delta plus Y2 times delta 2 over delta M3 times delta 3 over delta. Okay, so we can write M1, where is M1? Here. Maybe we can copy it. Yes. Okay, this is M1 divided by delta, of course, both of them. What about M2? M2 is here now. We can copy it. Okay, delta 2 is 1, we know it. What about M3? M3 is A12, A25. A12, A25. And delta 3 is 1 minus A44 minus A34, A43. Okay, that's all. This is the transfer function of the between the y5 and y1. If we want to know y4 over y2, before them, as you see here, if we want to talk about this kind of relation, first of all, we should know it. It should be input and it should be output. As you see here, y2 cannot be input and y4 cannot be output because y4 has outgoing branch and y2 has incoming branch. Okay, but if we modify it as like that, for example, if we say it will go to the y4 node. So if we want to find y4 over y1 relation, now what can we do? We want to find y4 over y1. What can we do now? As I said before, delta is the same for the same SFG. Okay, so we don't need to find delta again. Delta is the same for we are using the same SFG diagram. But forward path can be changed now. What is the forward path? M1 is we have, as you see here, a forward path y1, y2, y3 and y4. So A12, sorry, A23, A34. Okay, what about the delta 1 for this forward path? Is there any non-touching loop for this forward path? No, so we can say directly 1. Let's continue M2. Is there any other forward path? Yes, y1, y2 and y4. So the gain will be A12 times A24. And what is the delta for this path? Is there any non-touching loop? Don't use the y1, y2 and y4. No, so we can say directly delta 2 should be 1 again. Okay, is there any other forward path for the relation between the y4 and y1? No, so we can say directly m is equal to y4 over y1, a12 times a23 times a34 plus a12 times a34 divided by delta. Okay, we can find as like that.